Good evening to everyone.
Good evening, sir.
Okay. Refer question yesterday we asked. Tomorrow I will tell you about this. So
Yes, sir.
continue with the bridge equipment. Okay. Tomorrow I will tell you about it. So let's see about this VDR. We'll continue with this one. Data to be recorded in VDR. So first of all, this one data which is being recorded in the data collecting unit, and then it also going to the DRU, data recording unit. So data collecting unit, and from there it will be going to the data recording unit. So DRU, what all it is being recorded. First is date and time. The feeding of this one is going to be from the 6 o'clock. So date and time that will be going from the 6 o'clock. And 6 position. So this is a lat and long. So that will be going from the GPS. 6 speed. This will be going from the speed log. Here it also taken the reference from the GPS also, and this one is also from the GPS. 6 heading. It will be from the ship's compass, and that is mostly it is selected from the so it will be. Next is breeze and breeze wing audio. So there is a microphone. The microphones are installed in the breeze and breeze wing. From there it will be coming. Then VHF communications. So this is from the VHF sets. Radar data from both the radars. EIS data So it is going to come from the AIS. Inclinometer, data. It will come from the inclinometer. What is inclinometer? What it does? Anyone? Inclinometer? This provides about the list and trim. Okay, so this is there how much it is listing due to the role, page, or yeah, whatever it is, a list and trim that it is going to tell about that. Then there are the additional datas. And this is going to be like echo sounder. This is going to provide the depth, rudder order, and response. Hull opening data, acceleration, and hull stress monitoring systems. So from here, these two data will come about the hull stress and acceleration. Then in anemometer, it is going to give the wind speed and direction. Then there is a main alarms from AMS. So whatever the alarms are there in the AMS, not all, but important alarms of the MSP, ESP, engine, generators. So these are all alarms that is going to come from the AMS. Engine order and response. That is the engine telegraph. Then there is a safety. From the safety, we are going to have like fixed firefighting systems. Then there is a VIDAS. VIDAS is water ingress detection and alarm system. Then watertight and fire door status. Fire detection and alarm systems. Water mist system. Bilge whale alarms. Okay, so these all are alarms are there that is going to be recorded in the VDR.
Sir, what is this hull opening data?
Hull opening, if anywhere the hull that is open. Okay, so there is a indicator is there, like if you have duct kill. You know duct kill? Have you seen the duct kill?
No, sir.
Yes, sir. Bottom
Door
of the
is there.
engine room.
Yeah, door is there. In that there is an indication. There is a micro switch, and this indication goes to the bridge also. So like this, any hull opening is there anywhere. Okay, that is the important one. There is a indication that will be going. So these all are going to be recorded. Okay. Next, we are going to see about the marine radar. We will be seeing this. Marine radar. There is a SOLAS regulation for this, and that is same. It is given in the carriage requirement as per the chapter 5, that safety of navigation regulation 19. Okay, and in this there is a para 2.3.2, 2.3.3, and 2.5.5. So this says that all ships of 300 GT and upwards and passenger ships irrespective of size shall have a shall be fitted a 9 gigahertz radar or other means to determine and display the range and bearing of radar transponders and of other surface craft obstructions, buoys, shore lines, and navigation marks to assist in navigation and in collision avoidance. Collision avoidance. So I hope everybody know about the range and bearing. Range and bearing, like there is a display here. There is a radar display, suppose. So in the radar display, we are going to have a sweep. So this sweep, it is going to rotate 8 antenna RPM speed. Okay, so whatever the antenna speed is there, it is going to rotate at the same speed, this speed. Now we are going to have the, suppose we are going to have some marking on this one. So this is the shore line, like this. It is going to come. And there are the, whatever the ships craft around this one we have, like this marking is going to come. When we are going to, there is going to be a this one, this is known as a electronic bearing line, or in short, it is known as a EBL. Here we are going to have like 0 degree, this is the 90 degree, this side it is going to be 180 degree, and this side it will be marked 270 degree. So here we'll come to know where the electronics bearing line. So whatever the this is having, so it is going to tell us the bearing, means from us the direction of the target. Okay, so these all are which are appearing. This is known as a target. So it is going to tell the direction of target. Direction of target means this says direction of target, and this is only known as a bearing. Bearing. Okay, so in the radar we say bearing. Bearing is the direction of the target. For the range selection, we are going to have one ring will be there in this. One ring is going to appear like this. So just I will make here only. Like this, there is going to be a ring. This ring is known as a VRM. Virtual ring marker. So this ring, wherever we are going to align with the target, so it is going to tell us the range. Sorry, not range. This is suppose range marker. So this is going to give us the range, means how much the distance we have. Center is our own ship, and from here how much the distance is there. So range means it is a distance. So it is going to tell us the distance, okay, of target. So that is known as a range. And center is always our own ship, okay, from where the sweep is, the sweep which is rotating, that is known as a, from where the center, here it is going to have the center point, and that is our own ship. Okay, so this display is going to have many information, and that you might have seen in the sides, the range, bearing, target numbers, their parameters also going to come. We'll see about that, what all parameters are there. But this is the display that has the information. Now, it also says that in electronic floating aid or other means to plot electronically range and bearing of targets to determine collision risk. So this is a plotting. Now plotting is what? Basically, now suppose this is our own shape. So it is always going to be in center. Now suppose again I am making that display. Suppose this is a display. Here is our own shape at the center. And suppose one target is here. Now this target is continuously moving like this. It is moving. So we need to plot this one. So what we are going to do, suppose at this point, we are going to have the range and bearing. So we need to give this information to a device. So that is the electronic plotter or plotter, that is known as a plotter. So this is going to, we are going to give the information of this one. So there the first input has come of a target. Now again when it is changed next, so next input again we are going to give second input. So likewise we can give 3 or 4 input. Now if we give this 3 and 4 input, in this case it is going to determine the speed of the target. It will calculate the speed of the target. Not only the speed, but also it is going to, this electronic plotter, it is going to have the bearing of the target. Both it is given. So this is going to determine the closest point of approach. Closest point of approach. This is known as a CPA. And how much time it is going to take, that is known as a time of CPA. These two things are very, very important to have the collision avoidance. And that's why it is necessary to have an electronic floater. Okay, so we are going to give the input, 3-4 inputs if we give thereafter. It is going to determine the speed and bearing. It will calculate and it is going to give the CPA and time of the CPA. So this is the work of the floater. Next is all shifts of 500 GT and upwards. Now they supposed to have an in addition to this, whatever it is there, in addition to above, in addition to above. In addition, it's supposed to have an automatic tracking at or other means to plot automatically range and bearing of targets to determine collision risk. Now what is this? Now here it is saying an electric plotting ad, and here it is saying automatic tracking ad. Now these two are very different things. So let's see what we were doing here is we give to input to the electronic plotter. So first input, second input, third, fourth. Now if there is a automatic tracking is there. So automatic tracking, how it happens? Automatic tracking, in this case, we are here, one window is going to appear. One window will appear like this. Like this. So just I will make here so you come to know one window is going to appear. Now suppose this is a window. And here, suppose the target is here. At this point, we have the target. Now suppose the target is moving in this direction. So next, the position of the target is going to be there. Here. Now when it is coming at this point, so there is going to be the error. Okay, plus or minus error will be there because it is not at the center of this window. Now it has shifted here. So due to that error, the system will come to know and it will make means now this window which has appeared, this also will shift along with this because it is knowing how much which side the target has come. So target it is always going to keep, this window is going to keep at the center to the target. So this window also is going to shift. Now if the window is continuously shifting along with the target, so this automatically it is going to give the input to the electronic plotter. Now we no need to give each time input to the electronic plotter. Now it will be coming from the window itself. So this window is known as a tracking window. tracking window. Okay, so this is created, this is virtual, everything is virtual. And when the target is going to move, this also will move. And like that, each time the input is going to come the present position of the target to the plotter. So plotter is going to give the CPA and the TCPA, time of CPA, that is also known as a TCPA. TCPA, time of CPA. So this becomes now automatic tracking add. This is the automatic tracking add to plot automatically range and bearing of the targets. Now we do not require a separate plotter. Now, whatever the plotter is there, that means plotter will be there, but this window itself is now going to give automatically to this plotter the input. Okay, that means both are there in this one. If automatic tracking add is there, that means it is also going to plot automatically the range and bearing of the target. Okay, so this is known as the automatic tracking add. So all the targets, they are going to be tracked automatically. They are going to be tracked automatically. Now, second, it is saying is that all ships, that is again regulation 19, but the para, that is an, okay, I'll write like this, regulation 19 oblique 2.7.1, 2.7.2, and 2.8.1. So what it says about all shapes of 3000 GT and upwards shall in addition have a 3 gigahertz radar or a second 9 gigahertz radar. So either we should have a 3 gigahertz radar or a second 9 gigahertz radar. Okay, or other means to determine rest everything is same. Okay, rest everything is same up to here. Whatever it is there, from here to determine it is same up to here the collision avoidance. Okay, so just I am putting a dash here. You can copy from there, and it is going to be same till collision avoidance which are functionally in.
Sir, to determine afterwards, sir, 9 gigahertz or collision avoidance.
No, this I have put a dash, means you need to copy from top. Here. To determine, and you need to copy from here up to here, full. Okay, it is same. Everything is same. Correct? From here to here, it is same. Okay, you need to copy and put it here. Which are functionally independent. Means both should be separate. If second 9 gigahertz are there, that should be independent. There is no link between the first 9 gigahertz and this. Same way 3 gigahertz radar is there, there should not be any link with the 9 gigahertz radar. So functionally, it's supposed to be independent. And it is saying that a second automatic tracking ad or other means to plot, and it is again same, okay, up to collision risk which are functionally independent. So again, I have put here this one, this you need to copy from here. From here you need to copy. Okay, this you need to copy here. Then next it is saying that all ships of 10,000 GT and upwards. 10,000 GT and upwards. And automatic radar floating ad, and this is known as a ARPA, automatic radar plotting ad, or other means to plot automatically range and bearing of at least 20 other targets connected to a device to indicate speed and distance through the water to determine collision risks and simulate a trial maneuver. So trial maneuver we supposed to do. So one trial, that is a simulation we can do. Now here it is saying automatic radar plotting ad. Okay, and it's supposed to at least 20 other targets. Now what is this automatic plotting ad? One is the tracking. Okay, this tracking is already there. Plotter, you understood the plotter now, what the plotter is doing, electronic plotter. Now ARPA, what it is doing is, now suppose this is again a display, and suppose the ship is moving in this direction. This is the direction of the ship is moving. Now what I am going to do, I am going to make a sector. Okay, I am going to make a sector. This is a sector. So from here to here, there is a sector. Okay, suppose this is a 0 degree. So 30 degree this side, 30 degree this side, total 60 degree I have made a sector. And there is a range I have given also. So this range I have given, suppose this I have given for a 10 nautical mile. And suppose this I have given the range from my ship center positions. And this I have given 20 nautical miles. So what will be there, that any target that is going to, suppose this is a target, and if it is going to come here, automatically the window, tracking window will appear and the target number will be assigned. So whichever are having the targets, they are going to have their own numbers that is going to count. And this is supposed to be like, suppose this is the 1, this is the 2, this is the 3, this is the 4. Likewise, the total 20 targets is going to come. And all the 20 targets will be automatically tracked and plotted. Both the things will be there. Tracking and plotting both. If it is the tracking, it can plot automatically. Simultaneously, it is going to plot minimum 20 targets. But nowadays, if you see the radar, it is having more than 100 targets it can track at a time. Okay, 100 targets. About 100 targets it tracks. So that is the ARPA, and that is the advancement of the technology. So there is no issue of the 20 targets and all. It can track many targets simultaneously at a time. Okay. So this is the SOLAS requirement, and here it is saying very clearly the ships which is going to be 10,000 GT and upward is supposed to have the ARPA. So we are going to have the ARPA for the 3 gigahertz radar also. This is also going to have the ARPA, and 9 gigahertz radar. This is also going to have its own ARPA. Okay. So what is the basic function of the ARPA? The two things that simultaneously it tracks multiple targets, at least minimum is 20. And second, we can simulate a trial maneuvering. Trial maneuvering also we can do. So this is the two things are there. Okay, so these two things we supposed to able to do. Trial maneuver means we are going to simulate the targets, and we are maneuvering, means our ships, we are going to maneuver that. In simulator itself, we are doing that. Okay, so that is known as a trial maneuver for practice. So it is only for the practice. Hope it is clear up to here, the regulations. Now let's talk about the marine radar. So marine radar, it is a pulse modulated radar. It is a pulse modulated radar. Works in principle of eco ranging. Eco ranging. Okay. What is this eco ranging principle? This eco ranging principle is there that it is going to use, it uses electromagnetic wave. Electromagnetic waves. This is also known as a radio waves. It is going to have the speed of a light speed of light, and that is 3 into 10 to power 8 meter per second. This is the speed, which transmits from antenna and reflected wave. Reflected wave, same electromagnetic wave, which is going to come from the target or object. This object is also known as a target. It is going to reflected back from the object returns to antenna, and it is coming to the antenna and to receiver, and via receiver, we'll say via receiver to display unit. So in the display unit, this reflected object is being seen. So this is a very brief one. Now I have to tell you in the details about this. What is the echo ranging? Let's start from here. So you need to understand what is the pulse modulated radar first of all. Okay, pulse modulated radar. And second is known as a principle of echo ranging. Okay, these two are important. Now there are basically two types of radar is there. One is known as a continuous pulse radar, continuous radar. And there is another one that is the pulse modulated radar. Pulse modulated radar. Now in this case, the EM waves are transmitted continuously, non-stop. Now the object which is going to there, it is going to be reflected, and reflected waves is going to come. So suppose this is an antenna and we are continuously transmitting, whichever side it is directing, okay, it is going to transmit continuously. It is going to transmit continuously. And suppose here we are going to have the object and from here it is going to, this is the reflected wave that will be coming. And we are going to have a separate antenna for that one, and from there it will go to the receiver like this. So we are going to have a transmitter antenna, we are going to have a separate receiver antenna. Now, this was used in the World War time, and this is no more now. Nowadays, it is not being used because it is going to have the two antenna. That was the one disadvantage, like it requires two antenna. Okay. Then continuous transmission is again, we are going to do a continuous transmission. So a high power is required. High power transmission is required. And if the high power is there continuously, it is transmitting, then there is a cooling. So efficient cooling is required. And system is going to become very bulky systems. Okay, so these all were the main problems with this type of radars. So this type of radar is discontinued, no more it is being used. and we go for a pulse modulated radar. Now what it is doing, it is also doing a same thing. Okay. And returned, okay, and there was a determining in this one, determining the range, determining the bearing is okay, but determining the range was little difficult. Okay, was difficult. It is going to give you the bearing very accurately, but determining the range was little difficult in this one. So these all problems were there with this type of radars. So this has been discontinued. So we do not have this radar. Although we use this type of radar in our tank gazing and some others nowadays, but it is a very small miniature type of radars are there. Is that generally we use this one. Okay, otherwise for this all it is discontinued. Now let's see about the pulse modulated radar. What is this pulse modulated radar? Same thing we can achieve and the range and bearing very accurately we can determine with this type of radar. In this, what it is doing here, again we are going to have the antenna. Okay, this is the antenna we are going to have. Now, it is just sending, this is the transmitted, this pulse is being transmitted, pulse, again modulated pulse. It is being transmitted, here we are going to have the target. Okay, suppose this is the target. And again, this is being reflected back. Same, it is going to be reflected back. We are not going to transmit continuously. There is a pulse train that is being transmitted. Train of pulse. Okay, train of pulse. Pulses that is transmitted, not continuous. Continuous transmission is not there. That means we are going to have a transmission pulse here. This is a one pulse. And second transmission pulse is going to appear after some time like this. Okay, both are equal here. So this is a periodic cycle, means this and this one is train of pulses and there is a time difference between these two and this is known as a transmitted pulse. This is transmitted pulse. So this transmission is going to happen after certain period of time and that is known as a pulse repeating time, PRT. So this pulse is going to repeat after some time. So this is known as a pulse repeating time. Pulse repeating time. Okay, pulse repeating time. So this is going to repeat. So this is a periodic now. It has become a periodic. It is going to appear after certain period of time. That is a fixed period is there. And this is the transmission. Okay, this is being transmitted here for this duration. So this is a pulse. So this is a transmitted pulse from here to here. Now, from one transmitted pulse to second transmitted pulse, there is a time, and this time is known as a reception time. This is known as a reception time. That means one pulse is going, striking here and coming back. Again, second pulse goes, strike here, come back. Again, third pulse goes, strike here, come back. Likewise. Okay, so this is a reception time. So now if the target is there, we start calculating when we are going to sending this pulse. And as soon as the target that is going to appear here. Now suppose this target is appearing here like this. So we know the distance between this and this, because why we know there is a time. Because when I'm sending this one, I start counting, and thereafter when it is coming reflected back, it is going to appear. So the time I am knowing that one. Although it is traveling double, so I will be dividing by 2, but I can calculate the time here. And if I can calculate the time speed already I am knowing, so I can determine the distance. I can determine the distance. And this is how range calculation has become very, very possible by this pulse modulated radar. And all the radars are working in this principle. And this is known as a pulse modulated radar. And same works in the principle of echo ranging. Echo means which is the reflected waves that is coming. So this reflected waves, that is known as a echo of the object. So this echo, this is known as a echo, and which is going to come from the object. So it is going to appear in the display, so we can range it. So when it is going to come, this echo, so we can range, we can find the range, and that's why it is known as a echo ranging principle. Because I am sending a pulse, okay, and I know it is going and coming back after striking the target. Now the target which is nearby, that will appear here. If it is little far, it is going to appear here. If it is more far, it is going to appear here. Suppose this is going to go and come back, and suppose maximum range is 45 nautical mile, and suppose this target which is appearing is the 40 nautical mile. This target is suppose that is the about 22 nautical mile, and this is about the 10 nautical mile. So I can know now this target is at the 10 nautical mile, this target is at 22 nautical mile, and this target is a 40 nautical mile. So likewise, I can determine the range of the target. Okay. Hope you got the idea of the radar, how it is working. So these all are the pulse modulated radar, marine radars, and which work in the principle of echo ranging. Means the echo which is going to appear in the display, that is going to give the range of the target. Any doubt up to here to anyone? Now it consists of a transmitter unit, receiver unit, antenna display or assembly, sorry, did not display device or assembly, display unit, there is a synchronizer unit, and F is the power supply unit. So these all are there in a radar. Marine radar or any radar, you are going to have transmitter unit, receiver unit, antenna assembly, display unit, synchronizer unit, and power supply unit. This is the block diagram of the radar. This is the block diagram of the radar. If you see the block diagram of the radar, yes, you can see this is the block diagram of the radar. So this is the transmitted pulse or waves that is going, striking the target, again it is coming back. So this is the emitted wave or transmitted wave, and this is the reflected wave. Now this all synchronizing is done by the trigger unit. This trigger unit is also known as a synchronizing unit. Remember this one? So it is going to synchronize between the transmitted pulse, then receivers and the display units. All are going to be synchronized. So this trigger unit is giving the trigger and it is also generating the sweep. Not only the sweep, but EBL, VRM, these all are being generated by the trigger unit itself. Now, this modulator that is being charged by the power supply unit, and when it is being charged, there is a capacitor that is being charged. Not only the capacitor, that is known as a delay line unit. So that is being charged. And when the trigger is going to come from here, it discharges through the magnetron oscillator. So it starts oscillating. Once it is going to start oscillating, it is going to generate the high power, high frequency radio waves or EM waves. High power, high frequency. It goes to the duplexer. Through the duplexer, it goes to the antenna. Now, why we put the duplexer? Because this is a high power, it should not go to the receiver side. It will damage the receiver. That's the reason we are going to put this duplexer here. So high power should not go receiver side and it should go only to the antenna. So it will be going to the antenna, radiate to the atmosphere, reflected wave that will come through the antenna. Now again with the reflected wave that is coming to the antenna, it is going to be directed by the duplexer to the receiver. Receiver is having this all stages: RF amplifier, mixer, IF amplifier, detector, and video amplifier. So the echo which is coming of the object, that will be changed into the video and it will be appeared in the display. Now where in the display it is going to be appeared? Where the sweep is there. Now where the sweep will be there? Where the antenna is positioning. Remember this one. So where the antenna is going to position, it is transmitting, receiving also. And same place we want that it should present in the display. So this is how we are getting accurate bearing of any echo of the object, any object. And this is how we get the bearing, the direction. Range, because the echo is coming after certain period of time, so time we know it when it is going to appear. Accordingly, we can calculate the range. And this is how we are going to get the bearing and the range both. Bearing and the range both. Okay. We will go in the detail and I will give you some notes about this one. Then we will go for this replacing of the magnetron. That is important. So we'll see into that one. Otherwise, no much question has been asked in this. So little bit I'll give you the rough idea of all the small units, like what is RF amplifier, what is mixer, what is IF amplifier, this all. And thereafter we'll go to straight away for the magnetron replacement, because that is a question which has been asked. Okay, so you can take a break of 5 minutes, then again we'll start.
सर कंपोनेंट्स वाला सर एक बार पेज दिखा दीजिएगा, क्या कंपोनेंट्स लिखे हैं।
Okay, we'll come back.
Sir, you lastly told na sir, just one time told.
What is that?
That question you told na sir, that time my internet is corrupted.
Question they have asked about, just quickly explain what is the marine radar. And they are asking about the replacement of magnetron. So I will be also covering only these two topics. Okay. So just little notes I am going to give you on this one. So that will help you for your. Now this radar is basically acronym, and it stands for radio detection and ranging. So you can say RA, that is taken from here, D is taken from here, A is taken from here, and R. Okay, so it has become the RADAR, radar. So this is the acronym of the radio detection and ranging. So now that means what is the meaning of this one? The meaning of this, the radio waves that is used, radio waves are used for detection of object or target and finding the distance. Finding the distance. Okay, detection means in which direction it is. So that is the detection, and finding the distance. This is known as a ranging. So there is the range. Detection of object, that is the bearing. So bearing and range, this is how radio waves is used for that. So this is the acronym of the radio detection and ranging. Next is the radar uses EM waves. Already I have told you it uses EM waves, electromagnetic waves, to detect and locate the objects. It transmits a burst we can say, or trail we can say. Okay, whatever you feel, you can write it, or burst of periodic short pulses EM waves the object or target intercept a portion of transmitted EM waves and re-radiate in all the direction. Now antenna, why the antenna is being used? Antenna is being used, so we are going to have a small power and it can be concentrated. Okay, so like suppose we are having the antenna here. And
Sir, it will bit scroll down, sir.
it is 1 minute. It is going to transmit Okay, in this area only. So it is a conical shape. This is a conical shape. We are having the transmitted area. Means in this area, the pulse is going to go. So this is a conical shape. Now, if any target is there in this, suppose there is a target here. We are going to have a target. Now, this is a target. Okay. Now, the pulse which is going to come and it is going to strike back. But when it is striking, it is going back, reflected back by this one. Now, it is not going only in this direction, but it is going to go in all the directions, like this. So only a small portion that will be intercepted by the antenna, only this much portion of the reflected wave that is going to reach to the antenna, very small. And that's why whatever the power is required to transmit, the reflected wave power, it is going to be in the, sometimes it is going to be in the milliwatt. We have transmitted in the megawatt. Okay, this is the transmitted power. Remember, transmitted power is generally in the megawatt, and the reflected power, that is going to come back in the milliwatt. That means there is a losses. Okay, it is going to decay. The power is going to decay over the range, and when it is coming back, it is further decayed. And it will be just a milliwatt, a very small power that is going to come back to the antenna. And that is what I have written here. The object intercept a portion of transmitted EM waves and re-radiate in all the directions. So re-radiate in all the directions. So if the area is more of the radiation, power is going to be power is going to be reduced further. Okay, so it is going to be less. Now next is the antenna collects a portion of re-radiated EM waves and feeds to receiver to process and determine the presence of objects. These objects is presented in the display unit. Okay, it is presented in the display unit. Now, what is ARPA then? ARPA is a computer basically. Okay, so ARPA and display unit, these two things are very, very different. But it is a integrated systems in the display. So ARPA is another concern. It will be in the display unit only, but that is a processor basically. If you see the ARPA is going to, it is a computer and there is a program in that. So we will talk separately about the ARPA after this. Okay. Then next is this reflected EM waves from the object is called echo signal. It is called echo signal. Is used by radar to determine the direction and distance of the objects. So already I have told you it is a pulse modulated radar which works in the echo ranging principle. So just I am again writing this one. It is a pulse modulated radar works in principle of echo ranging. The time delay of return echo is returning only, returned wave or echo is a measurement of distance to the reflecting objects to determine the distance. The time delay of return echo is a measurement of distance to the reflecting from the reflecting objects, which determines the distance. Okay, distance measurement. So distance is going to be time travel into speed of wave divided by 2. So speed of wave, we know it, how much it is, 3 into 10 to power 8 meter per second. How much time it is going to take that? It is just a milliseconds. It will be taking in milliseconds. Remember this one? Okay. And because it is having a quite high speed and it is having 3 into 10 to power 8 meter per second. Okay, so it is just go and come back, divide by 2, that will give the distance. This is the simplest one. This is very complicated, distance or range. Finding the range, it is a very complex formula is there. This is the smallest formula that we can think of. Okay. Now, next is the direction of the reflecting objects. Reflecting objects we should not write. Reflecting, we should write the direction of the reflecting echo from objects. Okay, here also you need to change from the reflect distance from the objects. From the object that will be correct, which determines the distance. The direction of the reflecting echo from the object to determine the distance. Determine the distance. What? Okay, the direction of this one is from objects is obtained by the antenna pointing towards the object. So direction, how we are going to find? We are going to give the antenna data. Okay, so antenna data is antenna pointing towards the object. That data is given to the display unit. So you can see here, this is what it is coming. So this is known as a antenna information from the shaft encoder. So there is a shaft encoder that is attached to the antenna. And the angular position of the antenna that is coming to the display unit. So where the antenna is facing, which side it is facing, there only the echo is going to appear, means the object echo that is going to appear in the display. So in this way, we are going to find the direction of the object, and that is known as a bearing. Okay, so it is clear. Any doubt up to here? Anything you want to know in this in details? Okay, there is no question has been asked, so we'll be not going for anything else. Now we'll go straight away for the difference between X band and S band radar. X and S band radar. So this is the question that has been asked many times. Difference between X band and S band radar. So let's see item wise. So this is the items I will be writing here. This is X band and this is about the S band. Okay, so this is the item number. The first item is scanner. Scanner means antenna, which is scanning 360 degree. Scanner for the X band, it is going to be smaller. What is the size? That depends. It is going to be 4, 6, or 8 feet. S band, it is going to be larger. How much it is going to be? 9 or 12 feet. 9 or 12 feet. Now, if you see this one, this all depends upon the frequency. Okay, remember this. This all depends upon the frequency. If frequency is high, antenna is going to be smaller. If frequency is going to be low, antenna is going to be large. So it is indirectly proportional to the frequency. So in the bracket, just you can write inversely proportional to the frequency. Inversely proportional to the frequency 1 by L. Okay, so this is inversely proportional to the frequency. Now next, scanner motor. Now this motor depends upon make and model, but S band generally it is universal motor they are fitting or DC motor. So it can work on the AC and DC both, because universal motor that works on the AC as well as the DC. Okay, DC motor will work only on DC. So generally this one nowadays you will find it is a universal motor. So X band is going to have a universal motor. Okay, whereas the S band, this is going to have a 3-phase motor. And if the scanner is very big, then this is generally a synchronous motor. Okay, synchronous motor. Why the synchronous motor? Because synchronous motor is having the ability to maintain NS, that is the synchronous speed, at any load. At any load. Now, what is the load? The load is that is the wind. Wind is speed and direction. Okay, and direction. So due to this, there is going to be the load variation will be there. And if the load variation is there, and if it is a 12-feet antenna, 12-feet antenna, then if the wind speed is much higher, it is not going to maintain the same speed. Okay, and that's the reason why for that synchronous motor is going to be fitted. Okay, this is the one. Second, sometimes there is a also effect of the roll and pitch. Any rotating system, they are having also the problem with the roll and pitch. So load is going to come to the antenna. Okay, that is also known as a gyroscopic effect. I will tell you when I am going to teach you the gyro will come to know. Gyroscopic effect will be there. Third, frequency. So frequency, this one is 9.2 to 9.5 gigahertz, whereas this one is going to have the frequency that is 2.9 to 3.1 gigahertz. Fourth is wavelength. Wavelength is 3 centimeter, and here it is going to be the 10 centimeter. Again, the wavelength, okay, I will write here only. The wavelength, that is the lambda, is equal to C by F. C is a speed of EM waves, and F is the frequency. So this is the relation of the lambda. So lambda is equal to C by F. Lambda is wavelength, F is frequency, C is a speed of EM wave, 3 into 10 to power 8. Okay. Now next is power output, that is the transmitted power output we are talking about. not power consumption, but we are talking about the power output. 25 kilowatt. Okay. Oh yeah, this is the kilowatt. I was talking about the megawatt. We have the megawatt also, but here it will be kilowatt. This is a very small one, and that's why it is in the kilowatt. And 30 kilowatt. Now sixth, that is the range. Range is going to be short, and this range is depend upon the power. Okay, that is the transmitted power. Remember, if transmitted power, if it is going to be even frequency also, and if the transmitted power is less, range is going to be less. If transmitted power is more, range is also going to be more. Okay. Higher frequency is going to have the shorter range, whereas the small frequency is going to have the longer range. Again, it is depend upon the frequency and power both. Power and frequency both. The range depends upon this. 7, range resolution. Range resolution is going to be better in the X band, whereas it is less in this. 8, bearing separation. Separation means within the two targets, if both are nearby. Okay, so bearing separation means we can distinguish two targets better. Yes, in the X band it is possible, but in the S band it is not possible, so it is less. Bearing separation means if the two targets are nearby, we can identify there are two targets, so that is better in the identification, better in the X band, whereas S band we are having the. So that is known as a bearing separation. Same goes for the range resolution. Range resolution is same. If two targets are nearby, we can identify the different range of both. Yes, in the X band it is better, whereas S band it is less. That is the meaning of this. And there is going to be a SAT. There is a transponder. Transponder. This is also given in the SOLAS. SAT detection. Yes, we can do. No, in the S band. S band we can't do. So these all are the differences are there between the X band and S band. So X band and S band, this is the difference. Okay. Can you repeat the bearing? Okay, bearing. Bearing means direction. Okay, bearing means direction. Direction, how we are going to find the direction? So the antenna position, which side it is facing, antenna facing, because antenna is going to rotate 360 degree. Now, particular given time, which side the antenna is facing, that information is going to come from the shaft encoder that is attached with the antenna. Okay, so this is the angular position. So this is the angular position that comes. This is also known as a angular position. Angular position of antenna. So that is going to come continuously, and this will come to the display unit. Now the video which is coming is supposed to appear as per the antenna. So what we are going to do, we are going to generate the sweep. This sweep, this is a sweep. This sweep is rotated the same RPM of antenna. So it is having the RPM of antenna. Because the sweep generation is itself from the antenna information. So angular position will not be there, then sweep generation is not possible. And if the sweep generation is not possible, the target cannot appear in the display. Your everything will be okay. Your transmitter is okay, receiver is okay, but your target is not appearing in the display. That means your antenna information is not coming. Okay, so like this target will be appearing. So now we know when the antenna comes to this position, this target will appear. If antenna comes here, this target is going to appear. If antenna is facing this side, this target will appear. This is how the target is going to appear. Where the antenna is going to face, if target is there, target will appear in the display. If target is there. If no target, nothing is going to appear. Again, this side target is there, it is going to appear. Okay, so this appearing of the target direction, that is known as a bearing. This is known as a bearing. Okay, hope it is clear. Hiren, is it clear or anything else you want?
Yes, sir, it's clear.
Okay, good. Now, the performance monitor. So there is a performance monitor that is attached to this one. Okay, performance monitor. This performance monitor, it is again as per the regulation only, performance. Monitor. So this performance monitor is integral part, and generally all the ships which are on the international voyage, all ships of 300 GT and upwards on international voyage okay, shall have the performance monitor. So they are supposed to have this performance monitor. Now for the X-band radar performance monitor that is there in the Purno. Purno is a maker of the radar. They give the PM31. This is having the frequency 9410. So maker to maker, it is going to change. And there is going to be the X-band radar. And this is, the name is given PM51. And the frequency is 3050 plus minus 30 megahertz. Okay, so this is the performance monitor. Now what it is doing, basically, we want that our system is working correctly or not. So when we are going to switch on this performance monitor from the display unit, okay, this is going to be on. So we are going to switch on PM. PM is performance monitor from display unit. There is a button is given. You need to press that one, display unit. So press this button. In that case, when we switch on, the range will go to the range will change to automatically, change to 24 nautical mile. Automatically, whatever the range is there, it will go to the 24 nautical mile. And thereafter, in the display, so this is a display is there. Okay, suppose this is a display, and in display, the sweep which is rotating, there is going to be the arc that is going to produce like this. This is the arc you are going to produce. The range of this arc from here to here, the range that it's supposed to have, it's supposed to appear between 13.5 to 18.5 nautical mile. So between these, it's supposed to appear 13.5 to 18.5. If it is appearing, that means your transmitter, that is okay. Receiver is okay, means both are healthy. If no arc, you can see this arc, if no arc is present, then the magnetron has to be replaced. Magnetron is to be replaced. Okay. So this is the meaning. If the no arc, nothing is there, that means magnetron has to be replaced. Clear? So this is the performance monitor. This is how we come to know that our magnetron is okay or not okay. So it has to be replaced. Now the procedure for that one, tomorrow I'll tell you. I will start from here. Okay, and the remaining parts will finish. Then I'll tell you about the GMDSS also and the refer container. Okay, tomorrow I'll tell you because these all questions I have given to my engineers, the refer engineer, and he will give me the answer tomorrow. So I will tell you. Arc. What is arc? Arc means arc and sector, no? In the circle. Circle. There is a maths question. You are asking me arc. So this is known as a arc. Radius between the two radius, it is known as a arc. Okay. Not H. It is ARC. Arc. This is the arc. Okay? Is it okay? You understood what is arc? There is a circle. And between these two radius, this is known as a arc. And this is known as a sector. These all are the circle, arc, sector. You read in basics. That is the 8th, 7th, 8th, 9th class. You will come to know what is arc, what is circle, what is sector. This all will be done.
So can you tell one more time what is this 13.5 to 18.5 nautical miles?
13.5, this is the arc which is going to appear between this nautical mile range. This is a range. Okay, at this range, this arc will appear. If this arc is appearing, that means transmitter is okay and receiver is okay. Clear?
Okay, sir. Thank you.
Sir, another doubt, sir.
Yeah.
Sir, magnetron running hours is must, sir, if changed for magnetron.
Yeah, it will be given in the display unit.
Okay, sir. Okay, sir.
Oh.
Normally, how many hours, sir? Depend upon.
That depends upon maker to maker. You need to see that one. Maker to maker, you can find out, you can see that. Okay then. Okay then. Thank you. Thank you very much. Good night to everyone.
Thank you, sir.